Today, we will be reviewing fraction addition and subtraction, as well as decimal addition and subtraction. We're going to start off today with fractions. If you notice that both of these fractions do not have the same denominator, we do need to find the common denominator of both fractions to be able to add and subtract fractions. We use a strategy called finding the least common multiple, which is LCM. I counted by 6s and I counted by 5s, and I found that 30 is the lowest number that they have in common for multiples. What I'm going to do is change each fraction to a denominator of 30. What I'm going to do is rewrite each fraction with the denominator of 30, and I'm going to multiply each numerator and denominator to ensure that I have made an equivalent fraction. I'm going to figure out, what do you take times 5 to get to 30, which is 6, and if I wasn't sure, I could go back to my list of multiples, 1, 2, 3, 4, 5, 6, so 5 times 6 is 30, so I would have to take 2 times 6 to be able to get my new numerator of 12. I would do the same for the other fraction. So 6 times what equals 30? It's going to be 5. Again, if I wasn't sure, I could count on my multiple list, 1, 2, 3, 4, 5. And then I'm going to multiply my numerator by 5 as well, which is 25. The reason why we multiply both the numerator and the denominator by the same value is because really what we're doing is we're multiplying each fraction by 1. And anytime you multiply a fraction by 1, you keep the value the same, but what you're doing is changing the number so each fraction is cut into the same amount of pieces. What I would do then is to go ahead and subtract 25 and 12. If I wasn't sure, I could do that on the side. 25 minus 12, I would get 13. Therefore, I would have 13 as my numerator, and I'm going to keep the denominator the same of 30. I would want to verify if this is simplified or not, and it is. 13/30. I'm going to go ahead and do example number 2. This is addition. I'm going to follow those same processes, noticing that I do not have the same denominator, so I would need to find the least common multiple. I counted by 3 and 4, and I found that 12 would be the least common multiple, so I'm going to use that for my common denominator. I'm going to write 12 down for both of my denominators, and then I'm going to go back to the original fraction and multiply the numerator and denominator by 1. Or essentially, I would figure out, what do you take times 4 to get 12, which is 3. So I would multiply the numerator by 3, which would be 3 for my numerator. Then I'm going to multiply the denominator by 4 on the left-hand side fraction. So I'm going to multiply the numerator by 4 as well to get 8. What I would do is add my numerators together, 8 and 3, which is 11. And then I'm going to keep the denominator the same, which is 12. If I needed to, I would double check and verify if I needed to simplify, and I don't, so my solution is 11/12. At the very bottom, I've included some steps just in case, so you have an idea of what the steps are going to be. Make sure that you find the least common multiple for the common denominator. If denominators are already the same, you don't have to follow that step. You're going to also make sure we change fractions to their equivalent. So when I think about their equivalent, remember, I'm going to multiply each fraction by 1. Remember, that's going to change the numerical values from 2 and 3 to 8 and 12. But what it's going to do is ensure that my fraction means the same thing. Then what I'm going to do is add or subtract the numerator and keep the denominator the same. What I'm going to do is show you some strategies for decimal addition and subtraction. We're going to go ahead and start off here with 2 addends, 343 and 4/10, and we're going to add it to 5 and 607 thousandths. The most important thing when we solve decimal addition and subtraction problems is that we line up our place values vertically. What that means is that we would want to take our first addend, 343 and 4/10, and we'd want to add it to the other addend and line up the place values. What I like to do is line up the ones place. So the 5 and the 3 are in the ones place. So what I would do is put the 5 right underneath the 3 from the ones place, put my decimal place, and then 607 thousandths. Now this turns into kind of an interesting scenario because I have nothing to add it to the 7 and the 0 in this top add end. So what I would want to do is fill in zeros in the missing place values to ensure that to the right of the decimal we have the same amount of place values. So if this is the decimal place and to the right I have 1, 2, 3 place values, I would want to fill in the zeros above those place values to make sure that I add them up correctly. What I would do is add them up vertically. So I would have a 7 here, 0 and 0 is 0, 6 and 4 is 10, carry the 1, 5 and 4 would be 9, bring down the 4 and 3 because there's nothing I would need to add it to, and then bring down the decimal place. So my final answer is 349 and 7 thousandths. I'm going to use that same strategy when I line up decimal places when I line up place values vertically in example number 2, but we're going to be subtracting this time. So what I'm going to do is write out 94 and 9/10. I'm going to write my subtraction in my simplification bar. I'm going to look for the ones place. So the 4 and this 1 are in the ones place. So I'm going to place the 1 right underneath the 4, my decimal place, the 8, the 7, and the 1. Sure enough, I have 3 decimal places to the right of the decimal in that bottom number. Just in case if you weren't sure, the first number in a subtraction problem is called a minuend, and what you subtract from that minuend is what we call the subtrahend. So I need to add zeros in the place values right above that subtrahend. What I'm going to need to do, though, is borrow and regroup. Because if I have 0 or nothing and I try to take 1 away, I'm not able to do that. I cannot do that here or borrow from that hundredths place as well. So I'm going to go to the tenths place. I'm going to take 1 away from the 9, make that an 8, and bring the 1 next to the hundredths place. I'm going to go ahead and cross off that 10, make this a 9, and bring over the 1 for the thousandths place. Now I am all set to subtract. So 10 minus 1 is 9. 9 minus 7 is 2. 8 minus 8 is 0. I'm going to bring down that decimal place. 4 minus 1 is 3. And then I'm going to bring down the 9 because there's nothing to subtract from that 9. My final answer is 93 and 29 thousandths. So again, if you need some strategies to be able to add and subtract decimals, make sure that we line up the ones place in every problem. That will ensure that we can add or subtract vertically properly with each place value column. Please make sure you fill in the zeros for missing numbers. So again, if I have 3 decimal place values to the right, I need to make sure that I fill in the zeros either above or sometimes it could be below the number for the subtrahend or the minuend, or here with our add-ins. The next thing is to make sure we add or subtract each place value column. And if you're not sure the place values, I've written them out here. So again, the 5 is in the ones, the 0 is in the tens, the 2 is in the hundreds. There's our decimal place, and to the right of the decimal, the tenths, hundredths, and thousandths. What I would like you to do next is to go ahead and practice these problems. So I have some problems that have to do with fractions and decimals. I'd like you to take care of the odd numbers so you can check your solutions in the back of the book. Please make sure you complete these problems in your notes on the left-hand side where you wrote your examples.